Welcome back. As a quick recap from our previous video, so in order to do a BGP advertised networks, so we created a firewall address list. So we go to IP, firewall, the address list tab, then we have created an address list and the address or network or prefix that we would like to advertise. And in order to fulfill the requirement that the network that you want to advertise should be in the routing table, so since we don't have any connections to it, so we have created an example black hole route. So this is the one. We go to IP routes and this is our black hole route. So we have created this destination address, and if you see the black hole is check. And once we have fulfilled the requirement of an address list and the network in the routing table, so we did go to routing BGP and we have edited our connection to R1. So we are from R2, so we have edited the connection on R1 only. So we go to filter, then under output network, so we drop down and we only have one firewall address list. So this is why it's only this BGP advertised networks that is showing. That is similar to what we have done in R3. So we just go ahead at the routing BGP and we have created an address list and the routing table, and similarly we have only configured on our peer connection to R1, and under filter it's output network. So in R3 we have fictitiously wanted to advertise the 200 network, and on our R1 was the 100 network. So the end result was, if you go to the, let's try routing and BGP again as a review under session, so we have prefix count. So the connections from our peer R2 and R3 is advertising one prefix. And if you go to IP routes, so we have two BGP routes learned dynamically. So one from the 100, which is from the R2, and another one is 200 from the R3. So from here you might ask, or hopefully you might ask, if I have an IP route learned route, BGP learned route from my R2 and my R3, so would R2, which is having this 100, will learn also 200 from me? So R2 is advertising 100 and R2 don't know this 200 network, which is advertised by R3. So similarly, would also R3 learn this 100 route from R1, because R3 only knows 200 or fictitiously knows 200, which that is why he advertised it on R1. But would R3 learn through R1 the 100 route from R2? So again, to be aligned in routing BGP, we didn't configure the advertisement of 100 route on R3 connection, but we only made on R1. So to answer the question, is the simplest way will be to go to IP routes and take a look at the routing table and see if there is any BGP route. So obviously we know 100 because that's the one that we want to advertise, but we didn't see any 200 network which came from R3 because obviously they didn't configure, but didn't came from R1 as well, which R1 knows the 200 network. And in R3, if you go to IP routes, would he know the 100 network? So he knows the 200 network, but you don't see any BGP routes here. That is the 100 network that is coming from R1. Obviously, if it is really a requirement, so we could fix it by going to routing BGP and also similarly configuring in R3 connection the output network of 100. And in R3 as well, we could also similarly go to our routing BGP connection and our connection to R2, also inform our R2 with our network 200. But that is still in the realm of being okay when you have only a few BGP routers in your IBGP. So we only have R1, R2, and R3. So we have only 3, and we don't have that much effort in configuring the output network on the other connection. But what if, imagine R3, or in our IBGP, we would need to also create some connection on, let's say, another 9 or perhaps 19 routers. We are 20, so we need to make 19 or 9 connection. So it won't really do well if we go to each and every connection and just make that output network. Although it's not that hard, but still it's not that too easy or fast to do, because you will need to do it on the other connections as well. So the solution, or one of the solution, would be to have what we call in BGP a route reflector. So a route reflector is used to simplify the internal BGP or IBGP topology. So like I said, normally IBGP requires a full mesh. So every router must peer with every other router in the autonomous system. So this will quickly become unmanageable as the network grows. So the route reflectors reflector allows you to break this full mesh requirement by designating one or more routers to act as reflectors. Because if you don't realize, if you have 5 routers and we don't have a route reflector, so you need to have 10 sessions. If you have 10 routers, that is a whopping 45 sessions already. So here in our topology, we could make the R1 as our route reflector, and hopefully the routes that he learned from the other peer routers, for example this 100 or 200, will be then reflected, if we can borrow that word, to the other BGP routers in the IBGP topology. So enough with the introduction, but before we go to RouterOS version 7 configuration of the route reflector, so let's take a step back on the previous version, or on version 6, how it is done. So we have a MikroTik here that is on version 6. So if you go to routing BGP and you have the instance first, and just take a look at the default, you have the client to client reflection, check. Then under the peers, if you create a peer, you'll have the route reflect checkbox here. So now let's make our R1 the route reflector in our IBGP topology. So we go to routing BGP. So first we can go to templates and take a look what's inside the template that could be related to the route reflector setup. So general, and you go to extra, so you will see a no client to client reflection. So by default this is set to no, so meaning to say it doesn't disrupt the reflector setup, so it's disabled. So next, after we settle the templates, so we go to connection. So we have 2 connections, R2, R3. So on R2, for example, so general, so before we go to general, so extra, so we leave it like this, no client to client reflection, by default is no. So no, then plus no, so yeah, so it allows that particular setup. And then under general, so if we scroll and look into our local role and the drop down, so we now have the IBGP RR, that is for route reflector setup. So we would want our R1 to be the route reflector, so we will just select this and click OK. And similarly we will do it on R3. So we will leave the extra settings untouched, but on the local role we'll have the IBGP RR. So click OK. So here we have R1 on the left, R2 on the right. So as a result of that route reflector setup, so we now have on our R2, we learned the 200 route. So if we just quickly undo what we have done and make this as a non-route reflector, so IBGP, click OK. and our R3 as well to be non-IBGP. So click OK. So you see the R2 don't have the BGP route for the 200 network. So before we put back that R1 route reflector, so let's remove the peering connection. So for example, let's have routing BGP, then my connection to R3. So I'll just disable it. Then here in our R3, so similarly routing BGP, so my peering connection to R2, so disable. So obviously if we go to session, I will have only one session which is going to R1 because we have disabled. So similarly, that should be the expected result. So in our R3 BGP session, it also have only one which is to the R1. So now I have the routers displayed. So we have R1, we have R2, and we have R3 at the bottom. So before I put back the route reflector here in the connection, so if we take a look at the routes here, we have 7 routes. So if we scroll, we don't have that BGP route. So if we go to IP routes in our R3, so similar, so we have 7 and we don't have that BGP route. So let's check whether the routes will be added on our R2 and R3. So in our R1, so our BGP connection to R2. So let's now put back that IBGP RR role. And on our R3, we'll put back the IBGP RR role. So I see some changes already. So we have 8 here and we have 8. So let's just wait for the sessions to be up. So I now have sessions to R2 and R3, and I'll see the route list. I have 8, and let's take a look. Okay, now I have that BGP route for the 200, and similarly if we find that BGP on the 100 which is coming fictitiously from the R2 network.